This is Unit 8, Lesson 2, Operations with Rational Expressions. So we're going to take those rational expressions, pretty much just, once again, fractions with variables in your numerator and denominators, and go ahead, multiply, subtract, add, and divide them. All right, so we're going to start off with multiplication and division, because what we're going to notice is it's very similar to that whole simplifying thing that we just did in the last lesson. So let's just do a quick reminder of what it's like to multiply fractions with just numbers. Okay, so if we take the fraction, I don't know, 1/2 times 3/4. Okay, so we can go ahead and simply, we don't need a common denominator here. We can simply multiply the numerators and multiply the denominators. So in this case, I would get 3/8, right? Because 1 times 3 is 3, 2 times 4 is 8. All right, now what happens if you have something like 5/9 times, I don't know, 18/10. All right, so from there, I can surely go ahead and multiply and then end up reducing at the end. All right, in our first example, we had 3/8, which couldn't be reduced, or it might be easier to reduce first. In terms of numbers, it really doesn't matter, but let's go ahead and reduce first. So it doesn't have to be within the same fraction, or it doesn't have to be opposite fractions. Any factor of a numerator that has a common factor in a denominator can be reduced. So for example, the 5 and 10, I can divide both by 5. Okay, the 9 and 18, I can divide both by 9. Oh, well, in this case, I can also divide the 2's. So when all is done, I have 1/1. That just ends up being 1. Now, if I had gone ahead and multiplied first and done 5 times 18, I'm going to do a little quick math right over here. 0 raised to 4. That gives me 90. And then 9 times 10 is 90. And then I can reduce at the end to give me the 1. So it really doesn't matter whether I reduce first or multiply first. But when we get into our rationals, when we have variables, it will be so much simpler to factor first and then reduce before you multiply your leftovers. Okay, so let's go ahead and let's take a look at our rational expressions now. So our directions are just like they were with the simplifying. Factor, factor, cancel. We just have more things to factor first. Okay, so we're going to factor everything and then cancel common factors in their numerator and denominator. It's just that now I have 2 fractions as opposed to 1, or 3 as opposed to 1. All right, so the first example, there's really nothing to factor. I just have monomials. So we'll go ahead and cancel things out where I can. I notice I can reduce the 18 and the 6 if I divide them both by 6. I'm left with 1 and 3. My a's can reduce. I can get rid of one of them, so that leaves me with 2 up here. My 20 and 5, I can divide both by 5, leaving me with 1/4. I can get rid of both b's down here and 2 of them up here. Okay, so make sure you can see what's left over. It looks like I have 3a squared b squared, and I have 4 left over in my denominator. Okay, so once again, I could have multiplied first and then reduced, but at the end of the day, it's all the same thing. All right, now when I take a look at number 2, I do have some factoring to do here. A plus b and a can't be done. A times b, that can't be factored, but this down here can be. All right, so 1 times 2, so I need 2 numbers that multiply to 2 and add up to 3. So that's going to end up being a plus 2b times a plus b. All right, now I can cancel. Let's see, what can I cross off here? I can cross off the a plus b's, this a with that a, and I'm done. So I'm left with b over a plus 2b. Okay, so once again, more of just the same of what we did. Factor, cancel. All right, let's take a look at number 3. So this one I definitely have some more factoring going on. I have 4 separate polynomials that can be factored. So this first top numerator, I'll take out a GCF of x. That denominator I can factor into x minus 4 times x plus 4. All right, working at my second fraction. I can factor that numerator by 5y squared. I can take out as a GCF, which leaves me with 3x plus y. And then that denominator I can take out an x, which leaves me with 3x plus y. All right, it would have been a lot more work if I tried to multiply my numerator and denominator first and then refactored and cancel. It would have just been a nightmare. So factor, cancel, then we'll take a look at what's left over. All right, so what can I cross off here? 3x plus y, x minus 4's, this x with this x, and it looks like that's it. So I write what's left over in my numerator over what's left over in my denominator, and always leave it in factored form. All right, that's multiplying. So what I'd like you to do is pause the video and go ahead and try these U-tries on your own. They start off pretty basic, and then definitely make sure that you get to this one. Actually, before you do that, let's take a look at this last one together because there is something on there I would like to go ahead and point out to you. So first of all, there's nothing to factor, but let's take a look at this denominator here. 4 to the third and y to the third. We should probably figure out what that equals so I know what I can reduce. And when you do that, 4 to the third power is 64, and y to the third power is y to the third. So what's nice here is that 64, those cancel out. So I'm left with 8 minus y over y minus 8. Now, if you notice, these two are related. I'm subtracting the same things, but just in a different order. These two are actually opposites of each other. Okay, let's substitute, let's just, show you what's going on here. If I substituted a value in for y, I don't know, I'm going to pick the number 5. I could pick literally any number except for 8. All right, so if I do 8 minus 5, that gives me 3. And in my denominator, if I do 5 minus 8, I get negative 3. So these two, 8 minus y and y minus 8, are what we call opposites. Okay, because I'm subtracting the same two things, but in the reverse order, they're opposites of each other. So I can cancel them out, but look over here with our numbers. What is 3 divided by negative 3? It leaves me with negative 1. So I'm more than welcome to cross off opposites, and I would be left with a negative 1 in its place as opposed to a positive 1. So just be on the lookout for opposites. When once again, they're when I'm subtracting the same two things, but in the reverse order. It's not addition. 8 plus y and y plus 8 are the same exact thing. Okay, if I were to substitute 5 in there, I would get 13 over 13. Okay, not negative 1, a positive. So those aren't opposites. Opposites is for subtraction only. All right, please go ahead, pause the video, do those other 4 on your own. When you hit play, the work will be up here for you to look at. Pause now. All right, take a look. The first one just gave me 1/10. Okay, the second one I was left with 3y over 23. Last one, I was just left with 3b. Be careful on that one. X minus y is the same as x minus y. Those aren't opposites, so they just cancel. All right, and then the long one down here, I'm left with 2y. Okay, because I factored and pretty much every factor canceled out. All right, so we're going to move on to division. If you need to pause the video to take a look at the work more, please go ahead. But we're going to scooch down to division. All right, now guys, division is pretty much the same thing, except we need to flip that second fraction. Think back to when you learned about division with fractions. If you do 1/5 divided by 2/10, that's the same thing, hold on, divided by 2, over 15, let's do that. If we flip the second fraction, okay, KFC, keep, flip, change the sign to multiplication, whatever little gimmick you learned. But we're multiplying by the reciprocal, essentially, is what we are doing. And then from there, we treat it exactly like a multiplication problem. Reduce and then multiply, okay? So the 5 and the 15 can reduce. So in this case, I'd be left with 1 times 3 over 1 times 2. So we're going to do the same thing. Factor or flip, factor, factor, cancel. Okay? So I'm going to flip that second fraction. And if you want to write the factored form out as you're flipping, so you just have to write it less times, that's fine. Show you what I mean in the next example. All right, so I flipped that second fraction. I changed it to a multiplication problem. So I'm going to factor, 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 and cancel. So this denominator, I can pull out a 4, leaving me with x minus 5. Over here, I have x minus 5 times x plus 5, all over 2 times x plus 5. All right, now let's cancel. Let's see my x minus 5s and my x plus 5s. And that is it. So I have 3y in my numerator and then 4 times 2 down here. So 3y over 8. Nothing else can be reduced. All right, and my next one, let's go ahead and factor and flip. So up top, I can pull out an x and x plus 3. Remember, these two are changing spots. So this factors into x minus 2 times x plus 1, and that's now going to be in the numerator. This factors into x plus 3 and x plus 1. That's now in the denominator because I had to flip that fraction. And then from here, let's go ahead and cancel. So the x plus 3s, the x plus 1s, the x minus 2, so I'm literally just left with x. That's it. All right, so division, the only difference, flip that second fraction and then cancel. All right, once again, go ahead and pause that video and give these 5 problems a try on your own, and then we will get into addition and subtraction. Pause that video. All right, go ahead and take a look. Let me circle my other answers so you can see where they are. Okay, Go ahead, pause the video if you want to look through the work. I'm going to move on to the addition subtraction. One thing I'll point out, in the last one, you got 1. When everything cancels out, it's just 1, right? Because remember, we're dividing here. So when you divide two of the same fraction, factors are canceling out, leaving you with 1. Okay? All right, so pause that video if you need to take a closer look. All right.